Today we will investigate quadratic functions. Today I'll be giving you two strategies on how to identify the line of symmetry and the vertex of a parabola. Let's take a look at example number 1. We have y is equal to parentheses x plus 5 and x minus 1. So this quadratic function is in factored form, so that means we can easily get the x-intercepts. The x-intercepts are negative 5, 0 and 1, 0. Line of symmetry is always between the x-intercepts. So if you have negative 5 and positive 1, the line of symmetry will be halfway the 2 points, so it should be at negative 2. And when you draw an equation of a line passing through x equals negative 2, that will cut the parabola into two symmetric parts. So therefore, the equation of the line of symmetry is that x is equal to negative 2. And the vertex is at negative 2, negative 9. And we know that the line of symmetry will always pass through the vertex of the parabola. And it is halfway the x-intercepts. So if we will get the midpoints of negative 5 and positive 1, the midpoint is going to be negative 5 plus 1 divided by 2. And that means the midpoint is negative 2, which is also the line of symmetry. So the line of symmetry of this quadratic function is x is equal to negative 2. Since the line of symmetry will also pass through the vertex, and the line of symmetry is x equals negative 2, this means that the x-coordinate of our vertex is negative 2. So now we need to substitute negative 2 into the quadratic function. We have x is negative 2, so we have negative 2 plus 5, and we have negative 2 minus 1. Simplifying this, we have positive 3 and negative 3, so the y value is negative 9. And this means that the vertex of this quadratic function is at negative 2, negative 9. Now let's try example number 2. Y is equal to negative 2 parentheses x plus 3 and x minus 1. So this quadratic function is also in factored form, so that means we can easily get the x-intercepts. The x-intercepts are negative 3, 0, and we have 1, 0. And if you get the average of negative 3 and 1, that will give us negative 2 over 2 or negative 1. Which means that the line of symmetry, which is a vertical line, is x is equal to negative 1. Now we need to substitute negative 1 into the x of this quadratic function to get the y-coordinate. We have negative 2, negative 1 for the x, plus 3, and the negative 1 minus 1, which is negative 2, negative 1 plus 3 is 2, negative 1 minus 1 is negative 2. Simplifying this, we have positive 8. So the vertex of this quadratic function is at negative 1, 8. So again, if the quadratic function is in factored form, you simply get the x-intercepts and then you get the average of those two x-intercepts. Now let's have example number 3. Y is equal to 4x squared plus 4x minus 3. So this quadratic function is not in factored form. In fact, it is in standard form. If it is in standard form, the easiest way to find the line of symmetry is by using the part of the quadratic formula negative b over 2a. So in this quadratic function, your a is positive 4, your b is positive 4, and your c is negative 3. So substitute the b value. We have negative of 4. We have 2 times your a is 4, which is negative 4 over 8. In simplest form, it's negative 1/2, or negative 0.5. So that means the line of symmetry will be a vertical line at x is equal to negative 0.5 or negative 1/2. So the x-coordinate of our vertex is negative 1/2. And now to get the y-coordinate, we need to plug in negative 1/2 into our quadratic function. So y equals 4, negative 1/2 square, plus 4 times negative 1/2, and then we have minus 3. So y is equal to negative 1/2 square is 1/4. 4 times negative 1/2 is negative 2, and then we have minus 3. Simplifying it further, we have 1 plus negative 2 plus negative 3 or minus 3. So the y value is negative 4. This means that the vertex of this quadratic function is at negative 1, comma, negative 4. Our question 4 is equal to y squared is equal to x squared plus 4, which means that our a value is 1, b is 0, and c is 4. So in solving for the x-intercepts, we have negative of b, which is 0, and 2 times our a value is 1, which means that the line of symmetry is x equals 0, or that is the same thing as the y-axis. Again, solving for the vertex, we substitute x is 0, and if we plug in x is 0, we have 0 squared plus 4, so we have here a vertex at 0, comma 4. Now if we look at the graph of this quadratic function, we notice that it is also a parabola that's concave upward. The vertex is at 0, 4, which also happens to be the y-intercept. And again, we said that the line of symmetry is the y-axis, or x equals 0. Now let's have example number 5. Y is equal to 4x squared minus 12x plus 9. So in this problem, you can identify the line of symmetry by using, again, negative b over 2a. So we have x is equal to negative of negative 12, which is now positive 12. 2 times your a, which is 4. So x is equal to 12 over 8. And in simplest form, that is 3 over 2. So the line of symmetry will pass through the x value of 1.5 or 3 over 2. Again, the x-coordinate of our vertex is 3 over 2. Now we will substitute 3 over 2 into the quadratic function. So we have 4, 3 over 2 square, minus 12 times 3 over 2, and then we have plus 9. Simplifying this further, 3 squared is 9 over 4, so we have 9 over 4, minus 12 times 3, 36, divided by 2 is 18, and then we have plus 9. Multiplying 4 times 9 fourth, that's 9, minus 18, plus 9, and that gives us 0. So the quadratic function will have a vertex of 3 over 2, comma 0. Looking at the graph of this parabola, we know that there is only one x-intercept because the vertex is on the x-axis, 3 over 2, comma 0. And the line of symmetry will also pass through that vertex, so we have x is equal to 1.5. Now let's consider this quadratic function y is equal to 4x squared minus 12x plus 9. And if you look at the graph of this quadratic function, we notice that the graph intersects the x-axis at only one point, at 1.1.5, comma 0. The vertex of this parabola is at 1.5, comma 0, and the line of symmetry is a vertical line passing through that x is equal to 5. So the equation of the line of symmetry is x is equal to 1.5. Thank you for watching, and I hope that you learned something from me today. Please send me your suggestions and feedback to the comment section below, and help me achieve my aspiration to reaching out to more learners around the globe. Thank you, and don't forget to subscribe.